Welcome to the next mini lesson. This one is Chapter 2-5, Algebraic Proofs. Let's go ahead and get started. We did this in class on Friday and a bit on Thursday. We're going to make it a little bit more complicated. These are the properties I ask you to have flat out known, no ifs, ands, or buts about it. These ones right here are straight out of your book, and these guys right here we discussed in class that we're going to use for further justifications of some of the things we're going to do. The distributive property and simplify. Some people call this combining like terms, and I've heard other classes use grouping. Doesn't matter which one you use, I'll take either or. Let's take a look at our first example. What we have is an if-then statement. This is a conditional. Right here is our hypothesis, and right here is our conclusion. So this is our hypothesis and this is our conclusion. We're going to use our hypothesis and prove the conclusion through algebraic proof. I went ahead and typed this in. I got to be real careful, so I'm going to go a little bit slow because I want my handwriting to be somewhat legible. So I just copied the hypothesis right down here, and for our algebra proofs, we're just going to write given because that is our hypothesis is given. Hey, come on, right, there we go. Given. Our next step, B, we're going to start doing what we did in our algebra class. I'm going to distribute and solve for x eventually, but it's one step at a time, and it's all mental math. I have to spill over a little bit. Okay, so all I did was distribute. I know it bleeds over on these pluses and minuses especially. It drives me insane. I got to figure out how to get better at it. And all I did was use the distributive property. So distro, I'm going to abbreviate property. Okay, so we got C here. And it looks like I need to combine like terms, so that's exactly what I'm going to do. I'm going to have 10 of these guys. I still have my minus 15. And I didn't do anything to the other side. Minus 10. So all I did was combine like terms or simplify. And you notice I'm doing mental math here. I'm doing one step at a time. I don't get ahead of myself, and I have to justify everything. That is vital for a proof. If you start leapfrogging, you're going to say, well, what happened in the middle here? Prove it. Well, I'm going to get my x's to one side, so I'm going to make that 2x minus 15 is equal to negative 10. That's a negative 10. And what did I do here? Well, I subtracted 8x on both sides, so I'm going to use the subtraction property of equality. And I make sure I use subtraction, not substitution, so I abbreviate with the T there. That's communicating to me. That's perfectly fine. And P-O-E, because you do not want me to write with this pen property of equality all the way out. I would be here all day trying to get it neat. Next step, well, I'm going to get this guy right here, this negative 15, out of there. I'm going to add it to both sides. So I got 2x is equal to 5. And I use the addition property of equality. And of course our last step looks like it's just going to be x is equal to 5 over 2. And I used the division property of equality. I want my property of equalities on there. If you just put subtraction, addition, division, that's not telling me anything. I want the property that it's tied with. Let's be a little bit more formal and more precise on our proofs here. Alright, so what I did was I took my hypothesis and proved my conclusion right here. Let's go ahead and take a look at the next example.